All right, let's talk a little bit about the periodic table. 1869, Mendeleev and Meyer discovered periodic law. Mendeleev gets a little bit more of the credit because of the element germanium, and it had been undiscovered at the time, and he was able to correctly predict its properties, but both of them were toying with the idea of periodic law. Essentially states that elements are periodic functions of their atomic numbers. That is, the elements with similar physical and chemical reactivity will repeat themselves, and we organize those into the same vertical column or group on the periodic table. A period is a horizontal row, and it's just going to be sequentially numbered for each element. But it will start with metals on the left and transition to non-metals on the right. Several groups do have special names with special properties. You'll have your alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. It's that very first group on the periodic table, group 1A. Those are notoriously chemically reactive with water, for example, and I'll link in some videos for that so you can see them reacting with water, and they'll liberate some hydrogen gas. And I'll show you lithium, sodium, and potassium in the extra videos. And you can look on YouTube and see those reactions easy enough, but they'll liberate hydrogen gas in each case, and if it's exothermic or heat producing enough, it will ignite the gas, which is what you see with the potassium. Alkaline earth metals: beryllium, magnesium, calcium, strontium, barium, and radium. The heavier ones do react with water. Calcium on down will react with water a little bit as well. Group 3A is your boron group, so boron, aluminum, gallium, indium, thallium. Carbon group is group 4A, carbon, silicon, germanium, tin, lead. Nitrogen group: nitrogen, phosphorus, arsenic, antimony, bismuth. Group 6A is sometimes called chalcogens, particularly in organic chemistry: oxygen, sulfur, selenium, tellurium. Group 7A are your halogens: fluorine, chlorine, bromine, iodine, astatine. And your noble gases is group 8A, which is characterized by their notable lack of reactivity: helium, neon, argon, krypton, xenon, and radon. The B groups in the middle are your transition metals, the center elements on the periodic table. Offset to the bottom are your lanthanides and actinides. And those with the special names you should keep track of. For graphics' sake, here it is a little bit more graphically. All these in red in that first column, group 1A, are alkali metals. Note, hydrogen is a nonmetal, more like the elements on the far right. It is not an alkali metal, even though in some ways it behaves chemically like some of those metals. For example, it forms a +1 charge, like those metals do oftentimes. Your group 2A are these in this darker yellow color, or orange, whatever you want to call that. The B groups in the middle are mostly these blue ones all the way to zinc. Those are your B groups, and they are your transition metals. We didn't really have a lot of good names for some of these columns, but starting at 6A, this oxygen column was chalcogens. These are halogens. And then this very last column were your noble gases. Offset to the bottom, we have our lanthanide row, and they would insert back into the periodic table where this blue square is. And then that sort of bluish green is offset to the bottom is the actinide sequence. And again, there's a box in the main part of the table that's the same color, which is where they would go. Also, the periodic table starts with metals on the left to nonmetals on the right, and metalloids at the interface between the two. Metals tend to conduct heat and electricity very well. Metals tend to form cations by losing electrons, and they form ionic compounds with nonmetals. The solid state is characterized by metallic bonding, which can be strong in many cases. Nonmetals conduct heat and electricity poorly. Carbon in the form of graphite is an exception. It does conduct heat and electricity fairly well. They form anions by gaining electrons. They form ionic compounds with metals, but covalent compounds with other nonmetals. And we'll talk more about those two types of bonding a little bit later on. They form covalently bonded molecules with each other. However, the noble gases are monoatomic. There's a stair-step function on the periodic chart that separates the metals from the nonmetals. Metals are all those blue elements pictured to the left of the periodic table. They're about 80% of elements. Nonmetals are these in that sort of light orange, and including hydrogen from over here. And they're roughly the rest, or 20%. There's a few elements that are along a sort of stair step that's right here. And at the interface, you see nonmetals there in green: boron, silicon, germanium, arsenic, antimony, and tellurium. Some people argue about polonium and astatine, but on this chart, it's considering polonium a metal and astatine a nonmetal. And that should be the periodic chart.